Hi everyone, this is Professor Oaks, and this video is about solving rational equations. So what this really means is just solving equations that actually have rational expressions in them, such as this one, x over 5 equals x over 6 minus 1. So there are a lot of ways that you could solve this equation, but let me go ahead and I will rewrite this equation over here. So x over 5 equals x over 6 minus 1. And the first thing that I will do is just write this as 1 over 1, because that is another way to write 1. And then I will look at all of the denominators, the 5, the 6, and the 1, and find what would be the least common denominator. So that would be actually, in this case, 30. Alright, so then I will multiply each of the terms, and that means every term here will be multiplied by the least common denominator of 30. Alright, so there were 3 terms here, 1, 1, 1, so 3 terms total. And then we see that 30 divided by 5 is 6, so this will become 6x. 30 divided by 6 is 5, so this will become 5x. And 30 times 1 divided by 1 is still just 30. So now what I will do is notice that multiplying by the least common denominator eliminated all of the fractions here, which is good. So then I will subtract 5x on each side, so 6x minus 5x is just 1x, or just x. So the 5 minus 5 zeroes this out, so x is equal to negative 30. What a time to be alive. Alright, let's try another example here. So 1 over 6 plus y over 4 equals 3y over 8 minus 1 over 9. So let's look at the denominators here. The 6, the 4, the 8, and the 9. And let's try to find the least common denominator here. Alright, so if I look at the 6, that's 2 times 3, the 4 is 2 times 2, the 8 is 2 times 2 times 2, and the 9 is 3 times 3. So I know that the least common denominator then is going to be it's going to actually be 72, because if I look at this, I need to look at which denominator has the most number of 2's, and it would be right here, and which denominator has the most number of 3's. So this only had 1 3, but this had 2 3's, right? So the LCD is 2 times 2 times 2 times 3 times 3, which is 72. Alright, so I'm going to multiply each term by 72. So 72, 72, 72, 72, and then 72 divided by 6, alright, that is going to be 12, so 12 times 1 is 12, then 72 divided by 4, that is going to be, alright, what is that going to be? That is going to be 18, so plus 18y, and then 72 divided by 8 is 9, so 9 times 3y, and then 72 divided by 9, that's going to be 8, and then that's 8 times 1, which is just 8, so we have 12 plus 18y is equal to, well, 9 times 3, that's going to be 27, so 27y minus 8. Then I will go ahead and just add the 8 to each side. So I have 20 plus 18y is equal to 27y. Then subtract the 18y from each side. So I have 20 is equal to 9y. And then if I have 20 is equal to 9y, I can divide each side by 9 to get 20 over 9 is equal to y. What a time to be alive. Alright, so there you go. So, I really feel like the hardest part of this sometimes may be trying to find the LCD, but just remember that you're looking for the lowest number that all of these numbers can go into. The lowest number that the 6, the 4, the 8, and the 9 can all go into. And the lowest number that all 4 of them would go into at the same time is 72. Alright, so just remember that sometimes that is the trickiest part. Alright, let's try another one here. I have 1 over 5x plus 4 over x equals 10 over 3. So let's look for the least common denominator. So I have a 5x and an x and a 3. So I see that the lowest expression that all of these will go into is going to be 15x. So the lowest common denominator is 15x. So I'm going to multiply every term by 15x. So 15x, and then 15x, and then 15x. Alright, so 15x over 5x is 3, so 3 times 1 plus 15x over x is 15, so 15 times 4. And then 15x over 3 is 5x, so 5x times 10. So now I have 3 plus 15 times 4 is 60 equals 5x times 10 is 50x. Then we have 3 plus 60 is 63, so 63 is equal to 50x, and then I divide by 50 on each side, so 63 over 50 is equal to x. Alright, what a time to be alive. Alright, let's try another one here. So we have solve the equation below. What is the one positive solution? So we have 7 over 3x minus 2x over 3 equals negative 5x plus 4 over 3x. So I see that the least common denominator here, if I look at the denominator, should be 3x. So I will multiply every term here by 3x. So 3x, 3x, 3x. So 3x divided by 3x is 1, so 1 times 7. 3x divided by 3 is just x, so minus x times 2x. And then 3x divided by 3x is 1, so that's equal to just a 1 times negative 5x plus 4. So let's just simplify this here. 1 times 7, 7, minus x times 2x is negative 2x squared. Then that's equal to negative 5x plus 4. Then I will add the 2x squared to each side. So 7 is equal to 2x squared minus 5x plus 4. Then subtract the 7 from each side. So 0 is equal to 2x squared minus 5x. And then minus 3. And then I need to factor this because I see that this is to the second power, alright, so that usually indicates to me that it probably can be factored or that the expression is prime or cannot be factored, which then we will have to use other sort of methods that we haven't talked about yet to solve this, but that's okay. We just have to right now see if we can factor this. So we have 2x and we have x and we have a minus 3 and a plus 1. Alright, so you might need to review your factoring as well as finding the LCD, but that's okay. And now we'll set each factor equal to 0. So 2x plus 1 equals 0. And x minus 3 is equal to 0. So then subtract the 1 to get 2x is negative 1, and then divide by 2 to get x is negative a half. And that can't be the answer because the question asked for the positive solution. So x minus 3 is equal to 0. If I add the 3 to each side, x is equal to 3. And that is the positive solution. X is equal to 3. Alright, let's try another one here. So we have 7 over 1 minus x minus 9 over x equals 6 over x minus x squared. So I see that x minus x squared is really just x times 1 minus x. So if I look carefully, I can see that my LCD is x times 1 minus x. So let's go ahead and multiply every term by x times 1 minus x. So x times 1 minus x, x times 1 minus x, x times 1 minus x. So x times 1 minus x over 1 minus x. 1 minus x's divide out, so I'm left with x7 or 7x. Then minus, alright, we have x times 1 minus x over x, so the x's divide out, so I'm left with 1 minus x times the 9, and then that is equal to x times 1 minus x over x times 1 minus x, so that all divides out, so I'm left with just a 6. So now I distribute the negative 9 here, so I could write this as negative 9 times 1 minus x if it would make it easier for me to see this here. So then I have 7x minus 9, and then plus 9x is equal to 6. I'll combine the like terms here, so 7x plus 9x is 16x, so 16x minus 9 is equal to 6. Add 9 on each side, so 16x is equal to 15, then divide by 16 on each side, so x is 15 over 16. What a time to be alive. I really hope that you are enjoying this one here, so let's try another one. So we have 4 over 2x minus 8 is equal to negative 14 minus 7x over 4 minus x. Now this one is actually a proportion, so some people might just try to solve this one by cross multiplying, and that is actually fine if you wish to do that. Or you could go ahead and you could try to factor the denominator and see what happens. But let's say we just see it's a proportion and we go ahead and we cross multiply. Then 4 times 4 minus x is equal to 2x minus 8 times negative 14 minus 7x. Alright, so now what do we see here? Well, excuse me, so you would have to go ahead and multiply this all out. Alright, so you could multiply all of this out, and then you had 16 minus 4x is equal to, that would be negative 28x, and then minus, alright, what will that be? That will be minus 14x squared, and then, whoops, and then we have 8 times the 14 here, so that will be plus 112, and then negative 8 times negative 7x, it will be plus 56x. So then if I go ahead and I combine the like terms, so 56x minus 28x will be 28x, so 16 minus 4x is negative 14x squared. Then we have plus 112 and then plus 28x. Then I'll add the 14x squared to each side, so 14x squared, and then I'll rearrange this so that the minus 4x is first and then the plus 16. That's 112 plus 28x. Then I'll subtract the 28x from each side. So if I do that, I have 14x squared minus 32x plus 16 is equal to 112. Then I'll subtract the 112 from each side. So I have 14x squared minus 32x minus 96 is equal to 0. Alright, so now if I look at this here, so now I am going to need to go ahead and factor this here, but maybe perhaps I can see that I can, before I even deal with such large numbers, divide out a 2. So that will be 7x squared minus 16x minus the 48 is equal to 0. Alright, and then what do I have when I factor this? I have a 7x and a x, and then that will end up being a plus 12 and a that should be a minus 4. Alright, so then you set each factor equal to 0. So 7x plus 12 is equal to 0, and x minus 4 is equal to 0. And then here you would subtract the 12 to get 7x is negative 12, and divide by 7 to get x is negative 12 over 7. Or you would add the 4 to get x is equal to 4. But when you're dealing with these rational equations, you should always check your answer. So if I have 4 over 2x minus 8 is equal to negative 14 minus 7x over 4 minus x, and I go ahead and I try to check my answer here. So if I substitute in the negative 12 over 7 here, I have 4 over 2 times negative 12 over 7 minus 8. Does that equal negative 14 minus 7 times negative 12 over 7 over 4 minus negative 12 over 7? So here the 7's divide out, and here I see that I have 4 over, so 2 times negative 12 over 7 is negative 24 over 7 minus 8, and then I have negative 14, and then minus a negative 12 will be plus 12 all over 4, and then minus a negative 12 over 7 plus 12 over 7. So then what do I do? Well, here I make this 8 over 1, 4 over 1, and then I can just go ahead and, well, find the common denominator, so 7 over 7. So that will be 4 over negative 24 over 7 minus 56 over 7. And then here I have a common denominator of 7, so 7 over 7. So I have negative 14 plus 12 is negative 2 over 28 over 7 plus 12 over 7. And then negative 24 over 7 minus 56 over 7 is negative 80 over 7. So 4 over negative 80 over 7. And then 28 over 7 plus 12 over 7 is 40 over 7. Now here I multiply by the reciprocal, so 4 over the 1 times, alright, so make that 4 over 1, negative 2 over 1 times, and that will be, 7, negative 7 over 80, or 80, right, 7 over 80 or negative 7, 7 over negative 80 or negative 7 over 80, right, either way is okay. So then negative 2 over 1 times the 7 over the 40, so then we have 4 times negative 7 is negative 28, 1 times 80 is 80, and then we have negative 2 times 7 is negative 14, and 1 times 40 is 40, and then we can reduce each of these. So if I reduce this one, I can divide out a common factor that looks like it's just a 4, so that will be negative 7 over 20, and if I divide out a 2 here, I have negative 7 over 20, and both sides are the same, so that is one of the solutions. And then I should check if x equals 4 is a solution. So if I do that, that was the other solution, right? So this one is a solution. It checked out. So now I'm checking to see if x equals 4 is a solution. But then if I substitute in the 4 for x here and here and here, I have 4 over 2 times 4 minus 8. Does that equal negative 14 minus 7 times 4 over 4 minus 4? And then I see right away, hopefully, that you notice here 4 minus 4 is equal to 0, and I can't have a 0 in the denominator. So what I have is actually, if I do 2 times negative 4, all right, so that would be equal to, what is that, like 4 over negative 8, and then we have negative 14 minus 28, so that's 14 minus 28 is going to be, what's that, negative 42 over 0, but you can't have a 0 in the denominator, so that means that x equals 4 is considered to be extraneous because it doesn't check when I substitute the number back into the original equation. So x equals 4 is called extraneous, so it did not check out. So now that means that x is equal to negative 12 over 7 is the only solution. All right, now, of course, you might be thinking to yourself, well, this is a lot of work. I would absolutely agree with you. Even though you can do cross multiplying, and people love to do cross multiplying for some... All right, so now let's just look at this again, and let's say you have 4 over 2x minus 8 is equal to negative 14 minus 7x all over 4 minus x. As you can see, it took us a little bit of time to go ahead and try to solve this equation using cross multiplying. So I know a lot of times that people look at an equation and they think, well, cross multiplying looks easy because I already know how to do it and it looks familiar, but sometimes, like in this case, it definitely does take longer. So I want to definitely caution you against always just jumping to the conclusion that one method will be the easiest method. All right, so let's look at this problem again. And if I factor the denominator, all right, so I will have 4 over 2 times x minus 4, and then factor the numerator, so that will be, here we go, we have, you can factor a negative 7 if you would like, or a 7, it doesn't matter, but let's say that I go ahead and I write this as negative 7x minus 14, and then negative x plus 4, right? Then I could factor out a negative 7, so negative 7 times x plus 2, and negative 1 times x minus 4, right? So I have negative 7 times x plus 2 over negative 1 times x minus 4. And then I see that I have an x minus 4 in each of the denominators, but here we go. We have negative 7 over negative 1 is actually just 7, and 4 over 2 is 2, so we have 2 over x minus 4 equals 7 times x plus 2 over x minus 4. Now, these have the same denominators, so I'm going to just set the numerators equal to each other. So 2 is equal to 7 times x plus 2. Distribute the 7, so 2 is equal to 7x plus 14. Then subtract the 14, so negative 12 is equal to 7x. And then divide by 7, and negative 12 over 7 is equal to x. And that is the same answer that I got before. But then again, remember, look at all of the work that I had to do to go ahead and solve this equation using cross multiplication rather than by just trying to simplify and then find the least common denominator. So there we go. So sometimes cross multiplying is okay, and then other times it can definitely take you a little bit longer. All right, so let's try another problem today. So we have 1 over 6 minus 1 over 3 plus x. So we have 1 over 6 minus 1 over 3 plus x equals 0. So we say that the LCD is going to be the 6 times 3 plus x. So I'll multiply the first term by the 6 times 3 plus x. The second one, 6 times 3 plus x. The last one, 6 times 3 plus x. But that's still 0. All right, 6 times 3 plus x over 6. 6 divides out, so we have 3 plus x times 1. Then 6 times 3 plus x over 3 plus x. 3 plus x's divide out, so we have minus 6 times 1. So we have 3 plus x minus 6 is equal to 0. 3 minus 6 is negative 3, so x minus 3 is equal to 0. Add the 3 on each side, so x is equal to 3. Okay, so let's go ahead and try another one here. So I hope that you are enjoying this video right now. So here we have 9 over t squared minus 16 minus 5 over t minus 4 is equal to 6 over t plus 4. So just like a couple of examples ago where I went ahead and I factored the denominator, I will do that here. So if I factor t squared minus 16, it's t plus 4, t minus 4. So then I can see that the LCD is t plus 4, t minus 4. So I'll multiply every term by t plus 4, t minus 4. So I have t plus 4, t minus 4, t plus 4, t minus 4, t plus 4, t minus 4. So then here I see that the t plus 4 times t minus 4 over t plus 4, t minus 4, everything divides out. Then here I see the t minus 4 divides out, and here I see that the t plus 4 divides out, so I have 9 is equal to, we still have the negative 5, so negative 5 times the t plus 4 that did not get divided out. That will be minus, not equal, or equal. And then we have the 6 times the t minus 4 that did not get divided out. So there we go. So now, don't forget to distribute the negative 5 here and the 6 here. So we have 9 minus 5t minus 20 is equal to 6t minus 24. Then we'll combine the like terms. 9 minus 20, that's negative 11. So negative 5t minus 11 is equal to 6t minus 24. And then I can go about this a couple of different ways, but one way might be to just add the 5t on each side. So negative 11 is equal to 11t minus 24. Then we'll add the 24 on each side. So negative 11 plus 24 is 13. So we have, there we go. So we have 13 is equal to 11t. So 13 is equal to 11t. Then divide by 11 on each side. So 13 over 11 is equal to t. What a time to be alive. I really hope that you enjoyed this example here. So now let's try another one, and this next one will be similar to this one where we are going to need to start by factoring the denominator. So let's take a look at this exciting example right now. All right, so here we go. And again, we don't have too many of these left, so I hope again that you're really enjoying this. So we have 2 over the y squared minus 49 is equal to the 4 over 7 minus y, and that's plus. All right, and then equals 15 over 3y plus 21. So let's go ahead and factor all of these denominators. So the first one here is a difference of 2 perfect squares. We have y plus 7, y minus 7. Then the next one I can rewrite as negative y plus 7. So I have negative 1 times the y minus 7. And the last one I can factor out a 3. So 3 times y plus 7. All right, so before I even do anything else, I am going to take this and rewrite it as 4 over the negative 1 will be negative 4, and then 15 over the 3 will be 5. So I have 2 over y plus 7, y minus 7, minus 4 over y minus 7, and then that will be equal to 5 over y plus 7. The only reason why I'm doing that is so that it will be easier for me to see my least common denominator, and that will be equal to y plus 7, y minus 7. So if I multiply every term by y plus 7, y minus 7, y plus 7, y minus 7, y plus 7, y minus 7, I see what divides out here. So here, in the first term, both of the factors will divide out. Here, only the y minus 7 divides out, and over here, only the y plus 7 divides out. So I have 2 minus 4 times y plus 7 equals 5 times y minus 7. So let's go ahead and distribute the negative 4 and the 5. So I have 2 minus 4y minus 28 equals 5y minus 35. I'll combine like terms here. So 2 minus 28 is negative 26. So negative 4y minus 26 is 5y minus 35. And then let's go ahead and add the 4y to each side. So I have the negative 26 is equal to 9y minus 35. Then add the 35 to each side. So if I do that, I have that, well, what is that? That is going to be, what's that give me? That is going to be, 9 is equal to 9y. And then just go ahead and divide by 9 on each side. So 1 is equal to y, or y is equal to 1. All right, what a time to be alive. So there is the solution here. Y is equal to 1. So now, let's go ahead and switch to a couple of word problems before we run out of time here. So I hope that's okay with everyone, that we can try a few word problems here. So solve the equation below. What is the largest solution? And type your numerical answer to the one question that is asked only, and do not type any words or letters with your answer. Well, I don't see any equation here, so I guess that's not really a word problem. So let's try this one here. So suppose Steve can fix a car in 7 hours. Well, it takes John 9 hours to fix the same car. How long will the job take if both of them work together? All right, so let's say that it takes Steve 7 hours to fix a car. All right, so then let's just draw a visual here. So if it takes hour 1 hour, there's the first hour, second hour, third hour, fourth hour, fifth hour, sixth hour, seventh hour. So then if I know that it takes Steve 7 hours to fix a car, that means he can actually fix 1/7 of the car per hour. All right? John, it takes 9 hours to fix the same car. So let's just say that similarly, John will fix the car, like 1/9 of the car fixed per hour. Now, let's say that there's some other person, and I don't know how long it will take them to fix a car, but the pattern seems to be that it is 1 over x is how much of the car is fixed each hour. If x is equal to the number of hours it takes somebody to fix a car, right? So what you're going to do then is you're going to say, well, if they work together, that means that you're going to add the amount of time that they can work together. So, or how much of the car they can fix, you'll add that together. So 1 over 7 plus 1 over 9 is equal to 1 over x. So that's the amount of the car that Steve can fix each hour, plus the amount of the car that John can fix each hour. That equals the total amount of the car that they can fix each hour. All right. So now we see that the LCD is 63x. So 63x, 63x, 63x. So 63x over 7, that is 9x. 63x over 9, that's 7x. And 63x over x, that is going to be 63. Then 9x plus 7x, that's going to be 16x is equal to 63. And then divide by 16 on each side. So 63 over 16, that is going to be, all right, so that is going to be Oh, 3 and, all right, so x is 63 over 16, or 3 and 5, 15/16 of an hour. All right. Now, your answer is not in hours, it's in hours and minutes. So then you need to figure out, well, all right, you know, it's 3 hours and 15/16 of an hour, so it can't be 6 hours. And then you sort of go ahead and you say, well, all right, so I know that I have to convert 15/16 of an hour to the number of minutes that I need. So I know that there are 60 minutes in an hour, so I have 60 minutes, and then that will be 1 hour is equal to 60 minutes. So now I have a proportion to find that missing number of minutes. So let's go ahead and solve this proportion here. So let me find a piece of paper for us to do this with here. So again, I want to have 15/16 of an hour equals blank number of minutes. And I know that 1 hour is equal to 60 minutes. And so this is x minutes, the number of minutes that 15/16 of an hour equals. So I'll cross multiply. 15/16 times 60 is equal to x times 1, or just x. And then if I go ahead and I multiply this here, I have, let's see, what do I have? I have 15 times 60. So 15 times 60 is 900 over 16 is equal to x. And 900 divided by 16, that will be 56 and 0.25, or 56 and 1/4 minutes. All right, so then I know that the amount of time it takes Steve and John to work together to fix this car will be the original x, right? So 3 hours and 15/16 of an hour, or 3 hours and 56 and 1/4 of a minute. And so I just round that off to 3 hours and 56 minutes to the closest minute. I could go ahead and find the seconds even if I wanted to, but I don't think that that extra few seconds is going to really matter to Steve and John. They're just going to be relieved that they were actually able to fix the car on their own without any extra help or any explosions. All right, so I really hope that you enjoyed this example. So let's do one more word problem, or one more story problem, one more application problem right here. So we have, suppose robot A could paint a car in 3 hours, while robot B could paint the same car in 2 hours. How long would it take both robots working together to paint the car? So you would do this one very similarly to the last one. So robot A can paint 1/3 of the car per hour, and then robot B can paint 1/2, or half of the car per hour, and then 1/x is the amount that we're going to say that the robot A and robot B can paint while working together. Okay, so now let's go ahead and try to set up this equation here. So we have 1/3 plus 1/2 is equal to 1/x. We see the LCD is going to be 6x, so 6x, 6x, 6x. So 6x/3 is 2x, 6x/2 is 3x, and 6x/x is 6. Then 2x plus 3x is 5x, so 5x is equal to 6. And then divide by 6, so x is 6/5 or did I say by 6 or 5? 5. All right. I wrote 6 over 5, but I think I said divide by 5. It's okay. All right, because we still know that it should be 6 over 5 hours. All right, but 6 over 5 hours is 1 and 1/5 of an hour, but we see that it can't be 2 hours, 11 minutes. It can't be 1 hour. So now we need to convert 1/5 of an hour to minutes. So 1/5 of an hour equals how many minutes? And we know again 60 minutes is an hour, so 1 hour is equal to 60 minutes. So 1/5 over 1 is 1/5. That will be equal to some x over 60. So then I cross multiply. So 5x is 60. Divide by 5 on each side. So x is 12. So 12 minutes. So that means that the amount that the robots could get done, or how fast they could get it done when working together, would be in 1 hour and 12 minutes. So this 1 and 1/5 of an hour is actually 1 hour and then 12 minutes longer. All right, so there is our answer. Now you should try to remember that since Robot A could paint the car in 3 hours by itself, and Robot B could paint the car in 2 hours by itself, that if they are working together, then the amount of time that they actually could be getting it done in should definitely be less than 2 hours, unless one of them actually slacks off and takes a break because they're working together. And if they are, I'll fire both of them. Alright, so I hope that you enjoyed this video on solving rational equations, and I hope you're already looking forward to the next one. Thank you and have a great day.